First of all, the law of conservation of energy states that energy can neither be created nor destroyed, only converted from one form of energy to another. This means that a system always has the same amount of energy unless it's added from the outside. Three examples are: water flows from the sky, converting potential energy to kinetic energy. This energy is used to rotate the turbine of a generator to produce electricity. Second, when playing pool, the white ball is shot at a stationary 8 ball. The white ball has energy. When the white ball hits the 8 ball, the energy transfers from the white ball to the 8 ball, sending the 8 ball into motion. Then, when a moving car hits a parked car and causes the parked car to move, energy is transferred from the moving car to the parked car.
The experiment that I researched for consists of the exchange of the energy, and for this example we use the kinetic and the potential energy. The experiment will use these materials: a glass, something like rice to diminish the power of the fall, and a pencil or a stick with different marks. The marks are to count them and see how deep the pencil gets in the rice. To see the difference of the change of energy for the two that I mentioned, the kinetic and the potential energy, and depending on how much does the pencil get in it will be the total of energy.
Okay, we're gonna make an experiment. The material you have to need is a pencil, that's plastic board, and some rice. Okay, we need to make some lines to the pencil to identify the levels, because we're gonna throw it in different height and we're gonna see in which level it's gonna be. Okay, look, is how to look like this. Then we're gonna throw it to see in which level it's gonna be. Okay, look, is how to look like this. Then we're gonna throw it to see in which level it's gonna be. If we can see, it's in level 1. Okay, now I will do it more highest. We can see that is on the second level.
The law of conservation of energy states that in a closed system, isolated from its surroundings, the total energy of the system is conserved. In other words, energy cannot be created nor destroyed, only transferred or transformed. The SI unit is the joule, named after James Prescott Joule. So, there are many types of energy, but we will talk about 3: kinetic energy, energy of motion; potential energy, energy due to its position relative to its reference point; and mechanical energy, the addition between the two previous energies mentioned.
My name is Juan Rodríguez Salazar, and I'm going to talk about the problems involved in the practice conservation of energy. So here we have the problem. A pencil is at a height of 1 meter above a glass filled with rice. It has a mass of 0.50 grams and has a velocity of 3 meters per second. Calculate what is the potential and the kinetic energy that the pencil has. And here we have an image that represents the problem. So for this problem we need to remember the potential energy formula, that is potential energy is equal to mass times gravity times height. And analyzing the problem we get this data. the height is equal to 1 meter, the mass of 50 grams, and the gravity, we took the gravity of Earth, that is 9.81 meters per second square, and the velocity, that is 3 meters per second. So what we're gonna do is to substitute the values, and we get that the potential energy is equal to 0.004,090 joules. The kinetic energy formula is kinetic energy is equal to mass times velocity to square over 2. So we substitute the values and we get that the kinetic energy is equal to 0.0015 joules. And here we have other values, and in this problem it is the same problem, but we change the height the pencil is, and we get the potential energy that the pencil has at this height is equal to 0.122625 joules. And here the note and that I need to give is that if we have the object in a higher height, the potential energy will be higher, will be more, and that's it.
In conclusion is that the more weight is placed on what will be the apparatus in the part of the weight, this faster engine giving a result in less time in the apparatus that we used in the lab practice. My conclusion is that when more weight in the lab practice, more weight is placed on the apparatus, is less on time, and is more acceleration or velocity applied in the apparatus.
And my conclusion of this topic is you need to know how the exchange of energy is done, to don't have wrong ideas or the energy, or that if it is one energy it disappears this but the other appears. No, it's that one converts into the other, so there is the transformation.
My conclusion of the conservation of energy practice is that all the measures that we have, like mass, height, and gravity, affects in certain way the energy the object will have. But in this specific case, in our experiment, we looked at if we put an object into a higher place, the potential energy will be more.
My conclusion is that the different energy and formulas of how they were used, this writing was a great help as we got to know a little more about energy conservation. Therefore, energy is a physical quantity that can manifest itself in different ways, mainly potential and kinetic, with the possibility of transforming each other, but always respecting the principle of conservation of energy.
In conclusion, I think this law is very easy to understand, and once you understand this law, it will be really easy to see examples in real life.
Finally, as an individual conclusion, I really enjoyed creating this video talking about this law, because the conservation of energy really blows my mind due to the basic principle in which it is established on, that is, that energy cannot be created nor destroyed, only transferred or transformed. Thank you.